Next concept that we have is oscillations in LC circuit. What are these oscillations in LC circuit is all about? Let's take a charged capacitor. Its initial charge is Q0, and it is connected to an inductor, and this key is closed at time t equal to 0. What is going to happen? Initially, the capacitor starts discharging, right, like this, right? And then here we can see that in the circuit there is no energy dissipating element like a resistor. It means there is no dissipation of energy or there is no loss of energy. The total energy present initially is half CV square or Q0 square by 2C. This is the initial energy present. After infinite amount of time also, the energy present will be the same because there is no loss of energy from the circuit. But what actually happens to the energy over this period of time is what we are going to see now. I can say that the potential across the capacitor is equal to potential across the inductor. Potential across the capacitor at any time t is given by Q by C, and the potential across the inductor at any time t is given by L times of di by dt, the negative sign, right? Which can also be written as Q by C into minus L into di by dt can be written as d square Q by dt square, or d square Q by dt square is minus 1 by LC into Q. If you look at this differential equation carefully, don't you think it resembles like this? D square x by dt square is minus omega square x, which is basically the equation for an SHM, simple harmonic motion. In a simple harmonic motion, S is x equals to a sine of omega t, isn't it? So similarly over here, Q of t is equal to Q0 into sine of omega t plus 5 with the initial phase. What is this? Or it can be Q0 into cos of omega t. But let's see which one to use. Q0 into, we can remove the phi in that case, cos of omega t. Let's see, at time t equal to 0, the charge present on the capacitor is Q0. So out of these two, which one shall I use? I shall use the second one and discard the first one, because only when in case of second equation or second expression, the time t equal to 0, I get Q of t as Q0. So the charge on the capacitor is basically following an oscillatory. It's basically following oscillations. That means the charge increases, becomes 0, and then the charge reverses. What is the meaning of that reversing? So as soon as this entire Q0 is just discharged, this the energy which is stored in the form of electric field gets converted into energy in the form of magnetic field. And this inductor starts charging the capacitor again, making this the positive terminal or the positive side, and this as a negative plate. Until what point it does this? Until all the energy stored in the inductor is again converted back into the energy to an electrical field energy. And this oscillations keep on happening, right? So let's plot the energy for a capacitor as a function of time t, which is Q square by 2C. Q square is Q0 square cos square omega t by 2C. Since this part is a constant, cos square omega t would be like this. Right? This is how the energy in the capacitor would be. Similarly, the energy in the inductor also would be of the same way, but in such a way that in case of inductor, it would be like this. where here you have initially maximum energy, here we have initially least energy, so that the sum is always constant. That is what is important, right? This is about LC oscillations.